Hi fellow enthusiasts, welcome to my channel. Let's go into today's video and we're going to come back at the end to wrap it up. In this episode, we're going to show a continuation of the project from last week. We had shown this table where we were able to do the output, to display the output from the ATtiny or the microcontroller. In that case, we used an Arduino Uno. In this project, we want to show you how to replicate what we did last week using ATtiny instead of Arduino Uno. So in the project, if you remember what we designed, we built last week, we did some math, awesome, but we use an Arduino Uno as the microcontroller. In today's episode, we will replace that with an ATtiny. And there's a video we did earlier on how to flash ATtiny. So I'm going to put the link on this right about now, so you can go and watch that video again if you want to learn how to program ATtiny. But we built a PCB that we used to program this. So basically we have two videos. One of them is using PCB and the other one is using breadboard, but they achieve the same thing. We're able to program the ATtiny, and that's what you'll be doing. We'll put the links to both. You choose which one, the one that works for you. Now in this episode, now we flashed the code on the ATtiny already, so let's just demonstrate that, and then we'll go ahead and show you the code and how you can do that yourself. So here is a program here. Sorry, here is the project, and in this project I have my transmitter and the receiver. The receiver is powered by these batteries, 3.7 volts battery, two of them, so that's 7.4. and one thing we'll notice that is that the moment we plug this in, the flickering on the LED was gone. So maybe it's something you should try. And then once I press my transmit button, I get an LED blink on the transmitter, and at the same time there's a synchronous blink on the receiver. Now you see I have two LEDs on the receiver side. This one comes from the ATtiny, just to show that the ATtiny has responded to the signal. The one here is directly coming from the receiver, so you can measure the latency, if you will, how fast the receiver receives and interprets the signal from the time I pressed it. And then the ATtiny processes whatever is received and then displays it as an LED. This is just a demonstration. If you want to control something like maybe a toy car, something like that, then you want to use the different buttons to control right turn, left turn, move forward, move backwards, turn around, and so on and so forth. So if that's your purpose, you program each button to perform specific actions. So forward, right, left, reverse, and so on. All right. So we will show you how to display this signal also on the serial monitor for debugging purposes, to see what is going on as you were building this code, trying it out and trying to see what is going on. So let's just go ahead and put it in the serial monitor. So to do that, I'm going to remove the battery, then I'm going to power it through my Arduino Uno. So for this, I'm going to get my 0 volts and then my 5 volts. So my 5 volts come from 5. So jump one, plug in, jump one, plug in. Yeah, good. And then I need my data. Do I have a longer wire I can use for this data? Let's replace one of these wires. Let's replace this blue, this green. Just want to make sure that I connected it to the right place, so it goes on data, which is the next pin. I'm just going to test this, make sure that it still works. Right, I didn't get it right. So that's my data line. So data is here. Ground, and my middle is the VCC. So I'm trying to figure out where this goes. I just unplugged it. Ground, data, and VCC in the middle. Right. Right, so that's ground. That's my VCC. That's my positive power supply. Positive power supply is there. So this is my data. This is also my data. And this data Alright, so something is amiss right now. Something is amiss. Let's make sure we get it right. Before I use my out, alright, so we have got into some debugging situation. Okay, we're gonna try and make sure that the LED is still fine, because that's our indicator, our original indicator. So where's my ground? This ground. Alright, so the LED is still fine. We're just checking the LED, making sure that it's still fine. So this LED is a dual color LED, so the LED is fine, and we just want to make sure that the transmitter is still fine. Data is to the right, and that's data in. Alright, we get our receiver working fine, but the transmitter isn't. So we gotta fix the transmitter. We pulled one of the wires and it stopped working. So the center, this is the ground. Alright, so let's do the crude way. We're gonna try to send a pulse directly from here. Alright, so it still works. Alright, so we're sending pulse directly from here. Right, so it works. So we just want to check if this wire is good, because that's how we're sending the pulse. Alright, so the wire still works. Right, so then let's see. Our transmitter doesn't work. Alright, so we just plugged it in the wrong spot. Okay, so we're back. The wire was plugged in the wrong spot. So all this was just to get a longer wire. I could have just gone to my kits to get a longer wire, but I thought it was going to be faster. Sometimes trying to be faster, you end up being slower. Like, you know, like traveling and you're on the highway, you're running late, and instead of taking your time, you try to speed up, then you end up being even slower. Alright, so we have replaced the long wire, so because we want to have freedom to move this around. Let's apply the power, have the freedom to move this around a little bit. You can notice the flicker is back. We can put our capacitor back to remove that, but that's not our worry today. So we're going to show the serial monitor, and in this serial monitor, let's just see. I'll go in and make sure that I have the right board selected. Let's do the port first. I noticed that, okay, the right port is selected, and then we have the right board as well. Arduino Uno. If you use a different kind of board, please select your board. So if you see here, when I check my board, I have different versions. You can see these ones. So, but I have Uno. And then I'm gonna start my serial monitor. It's already started. So when I press, right. Alright, my monitor is not working. So let's see. Alright, I don't know why. Maybe because it was open before, but now we closed it and started again. Alright, so I'm gonna hide the camera so you can see the serial monitor and what it's doing. Alright, so clear, and then I'm gonna just press one of the buttons. Actually, you need to see the button I'm pressing, so instead I'm gonna move the serial monitor to the left, and then I'm gonna have my camera on again. Right, so when I press this button here, that's number one. On the serial monitor, it will tell you what button I have pressed. So let's see. So I've pressed button 1, then I'm going to press the second one. Button 2 pressed, number 3. Button 3 press number 4. Button 4 pressed, number 5. Button 5 pressed. So in that order. So when you press that, again, you can use that to program this motor. Button 1 go right, button 2 go left, button 3 go forward, button 4 go backwards, button 5 make a U-turn. So you can use that to program anything you want to do. Turn on the fan, turn on the light, and so on and so forth. The good thing here, the importance of what we've just done, is that we were able to use just one input output pin for all these 5 buttons, and then one output pin to go to the input output pin to go to the transmitter. So basically we are using only 2 of the available 6 input output pins on the ATtiny. So this is amazing, if I say so myself. So here you have PB0, 1, 2, then you have 3, 4, and then 5. So that's 6. So if you count them, there are 6 of them. 1, 2, 3, 4, 5, and 6. So you have 6 input output pins. My camera is covering this. So you have 6 input output pins: 1, 2, 3, 4, 5, and 6. And we're using just 2 of them. One as input and one as out. And this input can take as many buttons as you will. So far we use just 5 buttons, but nothing stops you from connecting 100 buttons. Again, it's all just limited. You're just limited by your imagination and by the size of the code that the ATtiny can take. Right now we are using 5 buttons. Then output will just be 1 output, of course, for now, because we want to send this to the transmitter. That leaves you with out of the 6, you can discount the reset if you don't want to have run the risk of resetting your program in the middle of execution. I can remove that, and then out of the 5 you are using just 2, leaving you with 3. And with these 3 you can do other things. You can do, let's say, temperature sensor, for instance. You can do temperature sensor, whatever you want to do. You can use another one for proximity sensor. You can do anything you want, to be frank. And then you still have one, you can use it for some other thing. So we're just going to call it +1, so you can just do whatever you want. So that's the beauty of this. And then if I solder this up, it will be very compact. Just imagine that I have this soldered. The resistors will all be compact. The resistors are small in size, so I can actually just put them very compact together. And then the switches, you don't have to use these big switches. You can use the smaller ones. And then and this resistor, you don't have to actually use this size, but you can use a smaller one if that's what you desire. Right, so let's just stop this from blinking constantly. Alright, this is not part of the program of the circuit. This is just a voltage regulator, but we're not using it right now. You will see it in one of our previous projects. I think the radio receiver, we use this on the radio receiver and the FM radio receiver. So we just put it in here as a placeholder. Alright, so let's look at the code. We made some modifications in the code. In the code, this is the transmit circuit, or the transmitter code, and that will flash on the transmit ATtiny. So we have a control pin A1, analog input 1. That is what reads, that connects to the resistors here. And then you have data out, which is 4, which is physical pin number 3. Physical pin number 3 is the physical pin number 3 of the ATtiny is the data for D4. So this one here is the physical pin number 3. So right, so this is the receiver, so let's just stay on the transmitter. Alright, so we're gonna close all this we used for some other thing. Alright, And then the rest of the circuit remained the same. The reason we chose these pins was to correspond with the ATtiny, and then I will left the serial monitor the same. Every other thing remains the same. No changes here. On the transmit side, no changes. And yeah, this is just for debugging purposes. We don't really use that now, so using it for debugging. So when the data is high, print 1; when it's low, print 0. That's for debugging. So it tells us when the signal generator is functioning, when it's creating the square wave. We just want to we use this for the monitoring, so not useful right now. You can comment your code so that in the future you don't start to wonder why you did what you did. So we've done that. So let's look at the receiver, because that's where the main work happened today. On the receive section, we have the transmit and receive. This is for the serial monitor. Again, we didn't use this receive because we're not sending any commands to ATtiny. So alright, so we added that, and again we have to include the software serial because we want to use the software serial library to create the serial monitor on the ATtiny. We've done this project before. As you can see, we're building up whatever we're doing. We start from the preliminaries and then we build up. So we've shown how to do build a serial monitor. If you want to watch that video, we're going to put the link on this video, maybe tomorrow. This is a live stream, so you can see there's some debugging we did at earlier stages when we unplugged one of the wires and we couldn't find where we took it out from, and then we have to debug and make sure everything is still fine. So this is going to be crude a little bit, but after it's posted live, I'm going to go in and edit it a little bit and include the links that I'm talking about. But there's going to be a link on the videos that we mentioned throughout this tutorial. It might take a couple of days to come, but it's going to come. And then so we declare that in the serial monitor here. So that video on ATtiny serial monitor, we're going to put the link about here in this as you're watching this. So we're going to have the serial monitor. So the transmit pin is 0. That is the input output pin 0 here. So pin 5, physical pin 5, that's the input. Alright, we don't need the transmitter anymore, so I can close that. Let's save the changes we made there. We don't need it anymore for today. And then yeah, basically everything remains the same. We declared we had 2 outputs. Remember, we had one red LED and red LED, and then we have a blue LED. So you have the 2 outputs. And then at the beginning we just turn them off. It should be off, but just in case, we just make sure that it's off when you start the program. It stays off. And then the interrupt, we didn't change anything here. It's just the way it was from last week, so you can watch that video from last week. And basically we changed the values here because we had to measure afresh what each button value gives with the ATtiny. Now if you've done this with the Arduino Uno, this is the important area of this video. When you press the button and you measure the interrupt, we're displaying the pulse, the value of the pulse, and you can see that on the serial monitor. Alright, let's see if we can get some values on the serial monitor and just use it for demonstration. Okay, serial monitor, we need to open a new serial monitor. Alright, so let's do that. We had serial monitor left from the previous, so that's why it was giving us that problem. Alright, so let's do it again. So when I hold the button, it gives me the value of 7142. So we'll write a code and we'll say if it is more than 1,000, which is way more than 1,000, then print out whatever the value is. And then if it's between 7,000 and a value, then I've pressed button number 1. I don't know that value yet, so I took this value and I say if anything is more than 7,000, yeah, obviously it will be within 7,140 as long as it is less than the next value. To find the next value, I press button number 2, and that button number 2 reads and gives me a value, and that value is 8820. So I said, okay, if the value that I get from the first button is less than the value I get from the second button, so I could just say 8832, but since the next button starts from 8832, I want to make sure that I don't encroach into that value. Otherwise, button number 1 might tell me that I've pressed button number 2. So that means, of course, that my button number 2 value will start from 8832. So you can see the first time I measured it, I got a different value. But if you're doing this, you will start from something more than whatever you can measure from button number 1. So you don't really have to. Let's press number 2 one more time and see. We're getting 8827. So we have to really start from 88 value. 88. Button number 1 never gets up to 8,000. Button number 1 never gets up to 8,000. So I can actually reduce this to say 8,000. No value that you get from button number 1 is up to 8,000. So it's still within 7,000 plus. So you can say as long as it is less than 8,000, you're pressing button number 1. Then for button number 2, we're getting 8,000 plus. So you can actually start from anywhere you want. You can actually start from 8,000, to be frank. So let's say 8,000. Anything from 8,000, yeah, because it's actually start from 8,000. Then you check button number 3. Button number 3, it's from 10,000. Let's see. 10,500, 10,500. So we can say as long as it's still less than, remember button number 2 never exceeds 9,000, to be frank. So you never reach 9,000. So you can actually say as long as this is less than 9,000, you've pressed button number 2. Then button number 3, alright, button number 3 has something around 10,000. So we can say for button number 3, if it is more than 10,000, so let's make it 10,000. If it's more than 10,000, and then less than, let's see button number 4. Number 4 starts from 12,000. 11,000, there's some 11,000 value there. So we can actually say as long as it is less than 12,000, if it is less than 12,000, then you have pressed button number 3. And button number 4, has something 12,000. I think some of these resistors are shaky. Number 4 from 12,000 plus. So as you can say as long as it is more than 12,000, so we can just say 12,000. Then you've pressed button number 4. And button number 5 is 13,000. Does button number 4 ever get to 13,000? No. So you can say as long as it is less than 13,000, then you press in button number 4. And for button number 5, as long as it's more than 13,000, you have pressed button number 5. So you can write this way and code it, flash it to your ATtiny. Again, watch the video on how to flash on your ATtiny. So for that, you have to go to example and Arduino ISP. You flash this code on your Arduino Uno first, And then you go back, go to Tools, select your board, change it to ATtiny, and you're using so here using Arduino as ISP when you're flashing it, and then you make sure that you select the right port, the one that you have your Arduino connected. Then you go to Tool, and then you do upload using programmer, and then that's how you flash it. Watch the other video to see the details. Alright, once you flash it, then these values, as you press the buttons, the values will be measured and it will tell you the button that you have pressed. Okay, that's how we wrote that code that you saw right there. So I'm just gonna undo the changes I made here because I already flashed this, and I can just save it. Okay. Alright, so I'm gonna close this. So that will be that on the changes we've made. Save changes and that. So build this and let us know. Put your comments, let us see what you're doing, and make a video suggestion what you want us to do next. In the next episode, we'll be looking at a transmitter and receiver circuit. Actually, we're just going to look at it, an FM transmitter. There's a new project that we want to do on radio receivers and transmitters. So let's see what happens next weekend if we get all the parts we're expecting for that. And we're going to build that. If we don't get all the parts, then we'll just do another video on maybe next gen editor and maybe radio receiver. Alright, thanks for sticking around to the end. That'll be it from us today. Please, if you have not subscribed, do so right now, and don't forget to like and share this video. Until we come your way again with more contents, stay enthused.